Hi, everyone. Welcome to the Future of Computer Vision. I'd like to thank you all for joining today. And as always, if you ever have any questions post facto of the event, feel free to email us at investorsupport@cloudastructure.com. Before we get started, we have our typical legal disclaimer, which I'll pause for a second and let you read it. As well, this will be posted in the chat as part of our offering circular. Okay, well, for those of you who want to do further reading on that, please take a look and click on the link in the chat. I'd like to welcome three amazing speakers today. Rick Bentley, our founder and CEO, who you all know quite well, but we have two new guests today on our computer vision team, Abik Sarkar and Oleg Labovich, and they will be having a great dialogue on where the future of computer vision is going. Essentially, they'll be talking about the artisanal history, what persistence is, a little bit of a discussion around GPUs, costs and challenges. And then, of course, we'll open it up for your questions at the end of their discussion. I'll let Rick and team take it away from here.
All right. Welcome, everybody. My name is Rick Bentley. I'm the CEO and founder of Cloudastructure. Today, we're going to kind of take you through what we're doing with computer vision, the challenges we face, how we overcome them, and what we got going on next. With me are Oleg and Abik. Oleg and Abik, please introduce yourselves.
All right. Hi, everyone. My name is Oleg. I'm working with engineers in cloud services in Cloudastructure. And yeah, every day we are trying to make our software or services more efficient and cover all our business cases that we have.
All right, Abik, say hi real quick.
Hi, everyone. So this is Abik Sarkar. I'm coming from India. I have been doing computer visions since past roughly 6.5 to 7 years, since it was mostly with very low power devices. I started out with Google Colab, which was pretty much in preview at that in those days, and started experimenting. I have seen a very big transition starting from days of TNNs to now Transformers and now to beyond. And we are having a team of 5 people who are working on these. And it has been a great journey and quite a lot of challenges here at Cloudastructure.
Oh, yeah. There'll be no end of challenges. So I'll talk a little bit kind of how we first started. We were originally just uploading video surveillance data to the cloud. So if the building burned up or blew up or someone came in and stole the recorders and the equipment, you would still have the video safely off site, right? That was the original idea. And that was a good idea, and it worked pretty well. The real advantage that we didn't understand that we had at the time was that once the video is in the cloud, we have access to really powerful computers. On an NVR, a video recorder, you really just have the CPU. And in the cloud, we can have GPUs, graphic processing engines, that are made just for processing video. So we can do computational stuff on video 10, 100,000 times faster, more efficiently, whatever, in the cloud than you can on premises on CPU, right? So when we first started, though, we were a startup in Silicon Valley. We were in some of the more prestigious accelerators. So we were given a lot of free credits. Google, Microsoft all gave us free credits. In fact, Microsoft gave us $360,000 of free credit, right? Pretty amazing. We're like, okay, we'll use it. So we had everything Dockerized so we could push our backend services to any host we wanted to. We moved it to Azure. They said, hey, we got this computer vision stuff you can use. So we used it. And we realized it just wasn't a good fit for us for several reasons. Probably the biggest one was, though, if you had a false positive, like there's this mailbox in front of this camera and the Microsoft software keeps saying it's a car, you can't train it. We didn't have access to their training models, right? So it's like we had computer vision on training wheels. So that's when I found Abik out there. Abik, actually, we were connected on LinkedIn, and he had done a program at his university where he had put up a webcam that would capture everyone's face as they came in to take attendance. Is that right, Abik?
Yep. Yes.
Yeah, that was years ago now.
Yeah.
So in the early days of computer vision, if you wanted to say detect a car, you had to tell a computer what a car looked like. And humans are really bad at this, right? You're like, okay, well, it's got two black round things at the bottom and it's kind of shiny on top, and there's lights in the back that are sometimes red, and in the front sometimes they're white, on the side sometimes they're yellow. They're kind of shiny. And so then the computer tries to find things that look like that, and it does a really bad job, and you try and tune it up, and it just never works that well. So that was computer vision really before 2015. And I was working at Google in 2015 when we open sourced TensorFlow. TensorFlow is a machine learning platform that was suddenly open and anyone could use. And it's kind of like the chat GPT and Bard of today, right? So it was a big deal when it came out. And so with something like TensorFlow, you're like, okay, hey, computer, here's 10,000 pictures of cars and 50,000 pictures that aren't cars, sorted out on your own. And it does. And it does a much better job than you can with this kind of drawing a picture for a computer what a car looks like. I think the big challenge in computer vision right now is probably persistence. Here's kind of how I describe persistence to people who are outside the computer vision space. The computer really just sees one frame at a time. It doesn't really do anything with the previous frame or the next frame. So let's say you're sitting in your house and the front door's open because it's warm in the summertime, and a dog sticks his head in. At first you'd be like, what's that? Is it a dog? Is it a wolf? Is it a coyote? Is it a monster? What is it, right? So the dog walks in and you see that it's a golden retriever. You see a full profile shot of the dog. You are now 100% sure that is a dog. You started out very unsure. Now you're 100% sure. You pet the dog. The dog turns around and leaves. As the dog leaves, you're still 100% sure that's a dog. Now let's look at it as a computer that's looking at everything frame by frame. The dog sticks its head in. The computer is still unsure, just like you were, if it's a wolf, if it's a coyote, if it's a dog. It comes in, turns sideways. It sees a profile shot. It's now 100% sure that it's a dog. The dog turns and walks out the door. The computer's only seeing its butt right now, and it thinks it's a sofa. So sofa is like it's 80% confidence, and dog is like it's 5% confidence. It doesn't remember that that's the same dog. It was just 100% sure about just a few frames ago. So Oleg and Abik, what do you think about persistence in computer vision?
And people are still, treating computer vision as an independent unit rather than treating as a continuous unit. When we talk about, like say detecting a person in a frame, we are not thinking about that person who has, come from a different room, or he's coming from, different angle. We are only thinking that person in that particular frame, in that particular setting. So that is something which is still a very good area to research in. And the other thing is, we are not looking at videos as videos. We are looking videos as a set of frames. Every time in computer vision, we only focus on frames rather than on videos. Because when we see as in cloud structure, the data, it's not an individual data. It's a continuous data with minor differences. And in those scenarios, we really need to learn what those environments are, because there is a possibility that, okay, there's a bench in the background which is of no use to us, and that's there like 24 hours a day, and we are detecting it always, but there's a person in front of us who comes just for a single minute, and he's the object of importance. We are not pushing so much importance to that. So right now our problem is we can be a 99% accurate system, but even if we are missing out 1% of the important events, I don't think so we are serving the purpose.
So one thing we're starting to do right now is in this Rorschach test of a blurred image, right, or image that's temporarily bad, we say, hey, we just saw a gun for one frame on a 24 frame per second video. And we didn't see a gun a second ago, and we didn't see a gun the next second. So maybe that was just something that looked like a gun but wasn't a gun, right? So let's look at some frames before and some frames after. And if we still see a gun in the frames before and the frames after, well, okay, then it probably is a gun, right? And this is kind of our first stab at persistence. Oleg, do you want to expand on this at all?
I would say that maybe it's also important to track the same object between different videos, right? Between different cameras, even, right? So if
Yeah.
it's possible to chain or identify the same object in different clips from different angles from different cameras, it would be super beneficial, right?
Yeah, that's even better than going from frame to frame. If you can follow from camera to camera, that's better still, right?
I hope so. Yes.
Yeah. Now, computationally, though, that's going to take some memory space somewhere of all the objects and where they're going, and that's going to impact cost and everything else. But I really think this is the future of computer vision. What do you guys think?
I loved the topic which you just mentioned about the cost, and that's where I think Moore's law help us because back when we started, the GPUs were costing huge, and what they were giving us, like the RAM was less, the computation power was less, but slowly now we are in generation of NVIDIA 4090. Probably by next year, we will definitely improve on our efficiencies. And the whole world is, especially after Chat GPT and all these tech now, all the buzzwords are coming out where people are so much fascinated with AI, the people who have not been impacted. So more people are focusing, more research and innovation is going into the field. And that is directly helping us to get the better drivers, to get better efficiencies. And this will definitely help even to push forward our own efficiencies.
I know Oleg's been working with Gregory on our own computer vision GPU clusters. It's really expensive to rent GPU time. You know, an RTX 3090 or 4090 that Abik just mentioned, those cards cost $1,000, $2,000 each. And Google or Amazon or Microsoft will be happy to charge you $1,000 or $2,000 a month to host one and let you use it, right? So we've got these big 4U computer boxes that go in a big rack in a data center that hold 7 of these cards. Now these cards are huge. They got big heat sinks on them, big fans, usually 3 fans per card, and you really can't fit many in a single chassis. We're running ours liquid cooled, so we have a water block on each one, and we cram 7 cards right next to each other in a single chassis. The fluid through those water blocks go to a radiator in the box, and then we can run 7 cards at a time, and we can stack a whole rack full of these. It only costs us a couple grand a month for the data center charge for that, maybe a few grand. So when we take the ownership of the cards on ourselves, we have access to a lot more computing power. Same way Google and everyone else does it. It really is the era of AI right now. AI is done with machine learning. Machine learning is done on GPU, right? There is a arms race going on between Microsoft and Google to build the biggest, human chat robot and all that sort of stuff. And everything's at a premium right now. I mean, for the last several years, buying a good graphics card for your computer at home was a challenge, right? So anyway, anything else you guys want to talk about while we're here on kind of what we're doing, what we're working on, and what comes next?
In really recent times, people were very skeptical regarding ChatGPT, or people were really skeptical about the big systems. Now these all things are possible. And once things are open sourced, once we start learning them, very good thing is we use a lot of open source things. So we are blessed to have a very tiny team who are using a lot of open source and agile structure. We can directly use the things. We can throw away things which are not needed, and we'll directly utilize all the things and make it a sooner reality than big companies. And one more thing I would like to add is our major aim in cloud structure will definitely for the computer vision would be to make video searchable to a human level possible, as human level as possible.
So I think one of the things that is really important that Abik was just talking about is our open source model. Open source software means you can see the source code and you can edit it, start your own branch if you want, etc. When we were working with Microsoft, and using their stuff, they wouldn't expose all the stuff to us that we needed to do a good job, right? So we're really in control of the software. We can write our own off of a popular branch, but even better, there's research teams all over the globe, all of whom they're much larger than the entire Cloudastructure team. We're still a relatively small company, and they're working on some detailed problem, face recognition, license plate reading, whatever. And then their stuff goes open source, and it didn't exist 6 months ago, and now it's the best in the world. So, well, let's use that one, right? And so it's very easy for us to do that. We're not married to anything. We don't have to do a lot of the deep research. We're more the technology integrator that takes best of breeds and makes it all work in a very efficient model. That sound right, Oleg? You work on a lot of the back end code stuff.
I do. There are a lot of open source tools, and we can choose the best one, right? But at the same time, usually the new features are not really tested very well with different, from compatibility perspective, right? And we are trying to support as many devices as we can, right? And it creates, from time to time, it creates an issues when old cameras, which uses very old, for example, FFmpeg, right? Push on us a video, and some open source tools might not be able to work with it, right? So, and it's very challenging to be able to identify all these cases and wrap it around with some kind of health check or try to heal. We had some cases when we were troubleshooting and saw the issues, and we asked open source team to help with that, like file the bug, and we got some support as well. So
yeah, and that's actually a really good point. Instead of one support rep, you have a whole community, with a forum somewhere, or sometimes you even get someone on live. So in conclusion, Cloudastructure is really at the leading edge of computer vision. We're really pushing the boundaries in a lot of ways, but we're still got practical solutions that work right now. And we're always striving to get better. So some of the things we're doing, we talked about the persistence and vision, looking across frames. That can be very computationally intensive. It can increase the workload by orders of magnitude, not just an order of magnitude. So we have to be very smart about how we do it. But we also want to make sure we take advantage of our cloud native platform. We have all the video in the cloud. We're not stuck on a little NVR, or even worse, a lot of our competitors are trying to do analytics on that teeny little chip in the camera that really drives the cost of the camera. And so they can't ship a big one with lots of overhead. I mean, if you're trying to do face recognition on a little chip in a camera versus do it in the cloud, you're just going to have a bad time, especially if you want to track that face, not just across cameras, but across locations, right? Those cameras don't have any way to talk to each other and coordinate as to which face they've seen and which ones they haven't. So while we're in the cloud, we're even pushing the boundaries there. We partnered with a manufacturer we found some time ago, who's a leader in developing water blocks for the PC gaming space. For nerds like me who like to play Fortnite with their kids or just by themselves or whatever, or other games out there, keeping the GPU and the CPU cool while you're gaming is a challenge, right? And you get a really noisy fan going, or you can liquid cool it. That's where the PC gaming industry is starting to go. And we're ahead of them on the computer vision side. And we can really run these cards hard and in a reasonable amount of space in our own type of data center space. So again, we're just pushing boundaries everywhere we can. We're trying to be the smartest people in the room. Sometimes we're not. We've made some mistakes too that are embarrassing to look back at, but we learned from them. We got better. So anyway, I just think it's really, really key to point out we're pushing the edge, but we're still doing things that are real. And again, we'll parse out our solutions up against anyone's of any size. We're really kicking butt.
All right. Thanks, Rick, Abik, and Oleg for that great conversation. Before we open it up to Q&A, just want to remind everyone that we will be having another webinar next month, April 6th at 9 a.m. on artificial intelligence, the next 5 years. We hope that you attend that one as well. It's going to be really a nice topic around the future of artificial intelligence. Rick Bentley will be the host of that session, and the link will be posted in the chat. Lastly, before we again get into Q&A, just want to remind all of you, if you so choose, if you want to invest, just go to buycloudshares.com and you will be led to the portal where you can do further investment or new investment if you're a newcomer. So with that, we'll open it up to Q&A.
Welcome, everybody. I put on a sweatshirt, it's getting a little chilly. I see some questions in the Q&A chat already. For everyone who's new here, we're a startup that is taking on the big incumbents to do computer vision, and we're doing it in a field where we think we can get paid nicely for it and provide them with a great return on investment. Let's see here, maybe I can pin. Oh no, I'm showing up on the front. Okay, great. So let's see. There are Q&As in the chat. So down here in the Zoom thing, there's a little Q&A thing at the bottom, and you can put your questions in. Yeah, so what's our account and customer base? Are you selling your products? Is there a planned time to go public? Okay, great. So some stuff we can talk about, some we can't. We're doing a Reg A Plus. That is like a mini IPO right now, where we can pull in investors who are non-accredited, which means we're before the IPO. So let me talk about this just a little bit. Let's say it was just 10 years ago, a little bit longer, and maybe 20, you were living next door to Mark Zuckerberg, and he was just a kid who had an idea for a website called The Facebook. And he was like, hey, if I just had $5 grand, I could really get this thing off the ground. And you're like, yeah, man, here's $5 grand. I believe in you. I came from the future. I'm Marty McFly or whatever, right? And I totally want to put in $5 grand into the Facebook at the early stages because I know it's going to be huge. And he would go to his attorneys and go, hey, this dude, Rick, just gave me $5,000. And the attorneys would say, hey, is Rick an accredited investor? He'd say, what's that? Well, is he worth millions of dollars, not including his house, etc.? And he'd go, no, he's just like the dude who lives next door. And the attorneys would say, you have to get the money back. You can't take money from a non-accredited investor before your IPO, before you're public. And so that would just be, that's just more rich getting richer, right? So now with the Jobs Act, they came out with Reg CF, regulation crowdfunding, and Reg A, which is kind of Reg CF on steroids, where you can take more money. Reg CF was originally capped at 2 million. We moved it to 5 million, and Reg A Plus is now capped at 75 million. So this is the way to invest in companies that are still early stage, but have enough going on to do a Reg A filing, which is about the same amount of work as going public, same, very similar reporting requirements. And we have to do audited financials and all that stuff. So anyway, this is just the setup is that's a way to get in on an early stage company before the IPO. Okay, so I think most of you already know that and are here and want to know about the company and how it's doing. I think probably a lot of existing investors on this call, which is fantastic. Always like talking with you all. So yes, we are selling products right now. We are transitioning right now, I would say, from early stage revenue to like real revenue. Last year was pretty flat as we got the product to the market. We had a little bit of an early pivot, not so much a pivot, an addition. We found out that a lot of our customers, okay, great, I got the video. And so I go to work the next morning and I find out that we got broken into, and I look at the video to see a bunch of people in hoodies with masks on because it's still COVID lockdowns and gloves, and I don't really have a lot to go on now. So what good is this doing me? Can someone watch this video for me and do something useful? Can the computer tell me what I'm being broken into, right? And where we are in kind of the continuum of artificial intelligence to computer intelligence, there's a line there somewhere, right, between AI and humans. And we're really pushing that boundary, but computers aren't good at subtlety. So they can't really tell the difference between two people swing dancing and two people fighting, right? They can't really tell the difference between someone having a stuck key in the lock versus using a crowbar to open the door, right? Humans are good at that though. These sort of subtleties we're very used to picking out the differences for, right? It's just part of our evolution. And again, it requires looking at stuff across multiple frames to get it right. So we came back with the concept of a remote guarding system. So the problem with remote guards is there's too many cameras and they can't look at them all at the same time, and they get bored quickly and they tune out, right? So the computer does all the boring work. The computer can look at 10, 100, 1,000, 10,000, 100,000, a million cameras at a time, and it doesn't matter to the computer, right? You can scale that up by turning on more boxes in the data center. And when it finds something suspicious, then it sends it to the humans for the final analysis. And then the humans can talk down. So now with the cameras, we also have speakers that are mounted. And the remote guard can talk and say, hey, you are on video. Yes, you in the blue shirt. Yes, you looking at the camera right now. You are on video. Put down the package and leave the premises immediately, right? Or whatever they're doing, right? And we can do that. Filtering the video up to the guards can be based on line crossing, object detection. There's a person in front of the building and it's after 9 p.m., right? Maybe that's just the time a guard needs to pop in and take a look and see what's going on. So in any case, that's been the big thing for us this year. And that's really allowed sales to uncap this year. We haven't announced our exact numbers yet, but 2023 is already off to a bang. I'd say we've seen unprecedented sales growth at Cloudastructure right now, based on that. And we'll have official announcements on that soon when we go to the lawyers and the numbers go out, right? Again, we have to be careful because we're treated largely like a public company with a Reg A+. So yes, we are definitely selling products right now. Is there a planned timetable to go public? As one of the first questions. Oh, I'm so looking forward to that. I can't even tell you. It's not an awesome market right now to go public, and going public is a bit like Fight Club. You're not allowed to talk about it until you do it, kind of thing. The lawyers get very uncomfortable. So we need to get the company to a revenue stage that makes sense to go public. It's probably somewhere around $1 million a month. We're not there yet. I'll say that much about our finances. We very much intend to get there, and then we very much intend to go public. We want to do it when it's the right time for everybody. We don't want to go out at some lame price. We really want to make a splash when we do it. So that is the plan. We all get paid on the management team when the stock goes liquid, right? And so we're all right there with you. This is what we want. If it was the same hot market it was 2 years ago, and we had the traction we had now, we might be talking about it sooner. I think right now we just need to, slow and steady is going to win this race. Not slow, but steady is going to win this race, and making calculated decisions. All right. Is 99% accuracy, sensitivity, specificity, or combined measure? Okay, great. Abik and Oleg, you guys are the more technical sides of the team. Let's jump in and talk about sensitivity versus specificity, or a combined measure, right? And what's the gold standard? I'm guessing labeled faces in the wild, but Abik or Oleg, you got any opinions on this?
Okay, I'll probably take this up. So it really depends on the use cases, and I'll define. There are two types of errors, right? So one error can be where I say that there's I missed a prediction and there was an event happening. The other can be there was no event, but I did give a prediction. Like, there are two types of errors. Now it depends what I want to eliminate. Do I want to eliminate the false positives, or do I want to eliminate the true negatives? So in our case, the major thing is, as Rick mentioned about the guards, we are okay sending more than required notifications to guards, and they can check, and they can be the ones who are eliminating all the false positives for us, rather than missing out the true events. So for us, here we majorly focus on eliminate like having as much events capture as possible. It's usually a words game. There's a matrix of the true events and the false events. It's a 2x2 matrix, and you can go with accuracy, sensitivity, F1 scores. But if you ask me about a gold standard, if in terms of computer, like in terms of classification, people use F1 scores a lot. But over here, we will probably, when training the models, we'll use some technical terms. But when dealing with our own data, we will use the different standards based on the use cases. Does that answer your question?
Yeah, for everyone else who's not as geeky as some of the rest of us are on this call, here's how I kind of describe the false negative versus the false positive. So a false positive is it think it saw a dog when there wasn't a dog, right? It says, hey, there's a dog. And you look at the video and there's no dog, right? Whether it could be a raccoon or just a raindrop that for a frame looked like a dog, right? There was no dog. So that's a false positive. A false negative is there was a dog and we said there was no dogs at that time, right? And that's a false negative. And everyone, yeah, talking about customer requirements right here, that's a great question. So every customer, here's what they want. They want a knob for false negatives, and they want a knob for false positives, and they want to turn both knobs down to 0 at the same time, right? And that's not how it works. If you say, hey, I never want to miss a dog. I want to turn my false negatives all the way down. So I want to see every single dog, no matter what. We're going to sometimes tell you a raccoon or a squirrel was a dog, right? Because for one frame, it really looked like a dog in there. And like I said, we're in the video previously, we are looking to work on persistence here. So we're averaging things out, but still, if you want to make sure that we never miss a dog, we're going to tell you there's a dog sometime when there wasn't a dog. The flip side could be, look, I don't want any false alarms. Don't tell me there's a dog there, because if there is, I have to get up and get dressed and drive over there at 3 in the morning and it's 90 miles away. So I never want a false positive, right? Only send me a dog if you're 100% sure there's a dog. We'll go, okay, great, we'll do that. But then sometimes there'll be a dog and we'll go, I wasn't really sure enough to wake that guy up to tell him there was a dog, right? So every customer wants to turn both down at the same time. It's really a slider, right? Where do you want to move it? And in our system, we do have a sensitivity slider. So in the system, you can actually say, hey, I want to be more sensitive. I want to find all the dogs, not miss any, but I'm okay picking up squirrels and raccoons. Or I want to be very unsensitive. Don't wake me up with an alert because you thought you saw a dog when there wasn't. And so the customer can set their own, basically. Hopefully that answers the question. All right, Silver, oh, one new message. Yeah, okay, great. What players, if any, have a market advantage against us? Well, I guess there's market advantage and there's technical advantages. I don't think many entities right now have a technical advantage over us. In fact, I would say some of the biggest competitors out there, like Cisco, which owns Meraki, have technical disadvantages over us. We really have a superior model. Let me explain why. Meraki, for example, does all the computer vision on the camera. Okay, so we're saying, hey, the NVR, the network video recorder, which has a Core i9, whatever Intel or AMD processor in it, isn't powerful enough for us. So we're going to push all the video to the cloud and run it there on the GPUs. They're going the other direction. They're saying we don't even need that big i9 CPU on the NVR. We're going to do everything on that teeny little chip. I mean, they're small on the camera, right? And it just is not going to work well. I mean, an example is how does a group of cameras not only, yeah, good comment on VHS debate. I'll get to that in a second. I'll use those terms too. But how does a camera do a good job with face recognition? But more importantly, how does it coordinate not just with other cameras on the same network, but other cameras at other locations, right? So let's say you've got a company who has 20 buildings and they want to know when a BIC shows up at any one of them, and you train them on one camera at one area, and then he shows up at another camera. You know, they're on other sides of firewalls from each other. These cameras can't even talk to each other, right? So there's just no way to get these little chips to do as good a job as you can in the cloud, and to communicate globally like the cloud can, right? So we've got real technological advantages over a lot of the bigger incumbents. What we don't have is a ton of money, and we don't have a huge team, and we don't have a household brand name, and we don't have a huge sales channel, right? So it's a very serious advantage the big companies have over us, right? They can kind of just bully their way into the sales process. And it's the old quip: no one ever lost their job because they hired IBM, right? Oh, they did a terrible job, they cost a lot of money, but it's IBM. What do you want from me, right? People have to kind of take a little bit of a bet on the smaller company. So where the chance, and this leads right into the next one, where the chance of being acquired by a bigger fish? I'll say this, a lot of these big companies, I think almost all of them, really their R&D department is their M&A department. And what I mean by that is they're fully busy supporting their customer base with the return to office policies and everything else, and just kind of being old school companies with the water cooler and all that. And they're not fast, right? But what they are is they're in a dominant market position. And so rather than take a risk on this new feature, this new concept, moving everything to the cloud when they're making a lot of money selling on-premises stuff, they just kind of sit back and they look at all the startups out there and they see which ones start eating their lunch, right? Which companies have taken out the technology risk, so they actually got it to work, and taken out the market risk. People are actually buying it, right? And when they see that combination of technology and market risk being taken out, and that company like us starts eating their lunch, hey, we lost another sale to Cloud Structure, they'll often come in with just big buyout numbers, right? Hey, let's buy them before they go public while we can still afford it, all that sort of thing. And you look at the multiple of revenue that they bought the company for, and sometimes it's staggeringly high, like when Cisco bought Meraki, right? But you scratch your head for not very long and realize, well, as soon as they slap their brand on it and shove it through their channel, the sales are going to go up 10 times or 100 times. So it justifies their crazy high purchase price, right? So what are the chances of getting acquired? We've had conversations from the beginning with the bigger companies. I think a little bit is they're trying to figure out what you're up to and how they can get some good ideas out of you. But also you keep those conversations going and see if someone wants to take you out before you go public yourself, right? Yeah, from the VHS and beta standpoint, absolutely. We think we're more open. We think putting it in the cloud just makes it more accessible. You don't need custom software to access it. I hear it all the time. Oh, the videos on our NVR inside of some proprietary software on a Windows machine. I don't know how to share this video with anyone, right? Ours is already in the cloud. Here's a link. You can send it to the police or your attorney or some other staff in the company who's across the country, just like that, right? Yeah, it's really, I don't know if people remember having their own email servers or file servers at the office. It's just a lot nicer when it went to Dropbox or Box.com or G Drive or whatever, right? It's just easier to share files now and make things useful. Same thing with Gmail or other email solutions online. It's just way better than hosting your own email server now. So that's the real advantage. So I think we're going to be the VHS and they're going to be the Betamax because where everyone is right now, everything's online now, right? And they're kind of selling the old school way of doing it with a Windows machine with custom software. All right, any other questions? I'm going through the list here. That might be it. one new message. Yeah. So Abik and Oleg, let's pick something for you guys to end on. Just what are, for each of you, what are the things that you think are most exciting to be working on, now or the next few years at Cloud Structure?
Okay, I'll take it. So for me, it's first of all scale. I'm waiting for more and more customers, for more and more cameras, and it should be challenging for our platform to be scalable, and it's super exciting.
Yeah, I mean, the amount of videos we have coming in as we get more customers with more locations, with more cameras is like a hockey stick. So it keeps everyone on the back end busy. Vic, what are you most looking forward to?
Yeah, as I mentioned, I think scale is a very good point from Oleg. But along with scale, once we have a lot more data, I think it will keep on improving our systems. It's kind of a combined answer between scale and compute, where with more scale, we'll get more data, and using more compute will make our systems more accurate. And it can be our, differentiate.
All right, fantastic. I think that those are both right. So with that, yes, there is a recording available. How many customers? That falls under the when we release financial information that has to go through all the lawyers and stuff. So sorry about that. It's just part of the road to the IPO. We have to cross our I's and dot our T's, other way around. But you get the idea. Yeah, there'll be a recording available. We'll have it up cloudstructure.com where this link was, I believe. And everyone who registered will get a recording also. So, okay, with that, Lauren, anything you want to close us out on, or should I just do it?
You can just do it.
All right. Thanks, everyone. It was a lot of fun. Oleg and Bick, enjoyed talking with you. Lauren, Kathleen, thanks for being here. And everyone have a fantastic day. Talk to you later.
Bye-bye.
Bye.